I was surprised. I'm not gonna surprise if it doesn't. I've not had that issue personally, as far as kicking out, but it wouldn't surprise me. Yeah, in the past with exams and stuff, I've not had any complaints about it, so I don't think it's going to be an issue, although I can't say that for a fact. But yeah, if nothing else, just just jiggle the mouse every once in a while on the Blackboard page. You should probably acknowledge it. And if it does kick you out, just log back in. Yep. So it's the Zoom meeting that you got to be more worried about. The Blackboard, if it kicks you out, just log back in. Yeah, and Casey, last time I did this about a semester and a half ago, the first part of COVID, I didn't have any issues with the submitting, although again, that's, no issues I heard about anyway. So, oh, we should probably get going here too. So, all right, so since we're starting class on time here. So again, don't forget about the practice exam. I will say in regards to the Zoom meeting that, as I found, again, kind of on your lines with the Zoom meeting, it was definitely kicking me out because I was doing other things on my computer. So chances are when you guys log in, I'm not going to be there because it's going to kick me out. Okay, so of course, during exam times, of course, I will be there the whole time. I will be doing nothing but, well, fortunately, watching you guys. Okay, so it shouldn't be kicking me out then, but just be aware. I'm guessing probably right now it's kicking me out of my computer, out of the Zoom meeting right now in my office. Okay, so just be aware of that fact. But again, as far as today goes, like, so you don't have to log into the Zoom meeting today if you don't need to. Okay, so okay, so I guess let's go ahead then and continue on here. So I'll make sure my pen's working. There it is. Okay, so we're doing these partial fraction stuff, or as I called it yesterday, magic. Yeah. Okay. So now, you may or may not have seen this stuff before, folks. I don't know that they actually teach this stuff terribly much in algebra pre-calc classes these days. But if you have, great, just be kind of a refresher for you. If not, we'll learn how to do partial fractions here. Okay, now, the one thing I want to kind of comment on before I really get started again with this stuff is, remember what I commented on yesterday. If we're going to partial fraction stuff, folks, the degree of your numerator has to be strictly less than the degree of the denominator. Okay, if it's not, you can't do partial fractions. So, and if that does happen, I'll show you how to deal with that on my last example in this section. Okay? All right, now, again, this table from last time again basically tells us again how to do partial fractions. Okay, so let's kind of just jump into this problem. This magic one I used magic on last time. So here it is. So again, in this case, degree of the numerator is 1, degree of the denominator is 2, and so 1 strictly less than 2. So technically, then I can do partial fractions. Okay, now. Again, first thing we're going to do with this always is just take your denominator and factor it as much as you humanly possibly can. Okay, so in our case, again, factors fairly simply. X minus 3, X plus a 2. Okay, so again, that's always the first thing to do. Okay, so factor that as much as you can, and then come up and just compare your factors to our table up here. So in this case, I've got two things that look like basically ax plus b. Again, a little a being 1 in both cases, of course, and b being a minus 3 there, and a plus 2 for that second. Okay, but basically, two terms like that. So that means my partial fraction decomposition, the thing over here on the right side, is going to get two terms that look like this. So capital A over little ax plus b. Order you put them in does not much matter. So let's go with the order I've got them listed here. So a over, or capital A, should be careful how I say that, capital A over x minus 3. Oops. And then plus capital B over x plus 2. Okay, so simple enough to break this up when you get what I call the partial fraction decomposition here. Okay, now, how you proceed from here, folks, is there's kind of a couple of ways to proceed from here. And the other thing I got to kind of warn you about, folks, is there are a lot of little tricks out there in the world that can be done to help you do partial fractions. Sorry about that. That can help do partial fractions. Now, the one thing that I want to kind of be careful of, folks, is or warn you about is, in general, I hate tricks. Okay, and I hate tricks simply because, well, they're tricks, and they're called tricks because they don't always work, and that's the problem with tricks. Okay, is you have to understand the limitations of the tricks. Now, having said that, I am going to promptly teach you a trick with this, because the way that always works for partial fractions, you don't do it unless you have to, because it's just painful. And I will show you the way that always works, because sometimes you have to work. Basically, again, those tricks break down on a pretty regular basis, folks. Almost every trick I have ever seen requires things all to look like that. Linear terms to the first power. So ax plus b to the first power. If they're not, every trick in the world I've ever seen promptly breaks down. Right? So And unfortunately for you guys, you're going to see things don't fall into that. So tricks aren't always going to work. Now, regardless of how you want to do the trick here, folks, okay, what are we trying to do here? We're trying to figure out, of course, the value of A and the value of B so that this right side over here is exactly equal to the left side. And when you combine everything back up. And in fact, that's the first thing I'm going to do. It always seems odd. The first thing you do is, of course, you break up into your partial fraction decomposition over here, and you probably turn around and put it back together. Okay, but that's always the first thing we're going to do here. So basically, common denominators and put this back together. Now, this is something you have done. Okay, whether you've done partial fractions or not, you have combined up fraction rational expressions in an algebra class. Okay, this is something they probably made you guys work a lot on way back in an algebra class. Now, first thing to remember, of course, is you need your least common denominator. And of course, for you guys in this class, it's nice enough your least common denominator is always your denominator from the thing I've given you. Yeah, that's always what's going to be. So in this case, of course, least common denominator again is x minus 3, x plus 2. Right? Technically, remember what you have to do. You need common denominator in the first one, so multiply top and bottom by x plus 2. Second one, we'll multiply top and bottom by x minus 3. Yep. And then add the two things together. Or a better way to say this, at least I think a better way to do this, is it's basically A times what's missing. Well, what's missing is the x plus 2, so A times what's missing. There it is. Same thing for the second term. B times what's missing. Well, what's missing is the x minus 3, so there you go. Okay. It's always real simple to get those numerators. Just ask yourself, A, or your numerator over here times what's missing from your denominator. Numerator over here times what's missing from your denominator. There it is. Add them up. Real simple to do. Okay. Now, again, making this clear here. Yeah. So what we're looking for here is, so I want to find A and B. So right side equals left side. Oops. Just written down here. Now, this is the thing that's kind of important here, folks. Okay. And it's so important. Let's capitalize it. For all x. Okay. So no matter what x I plug in over here on the right side, once I get the A and the B, the right side has to equal the left side. Yep. Okay. Now, here's where the trick I'm going to use, or actually the trick here, folks. I've still got more stuff, I guess, where the trick comes into play here. But the next thing we want to do here is set our numerators equal, because let's first notice what's written down here. So set our numerators equal. There's my abbreviation for numerators. I refuse to write that word up all the way. So numerators there. First thing to notice up here, of course, is that our denominators are exactly the same. So if we're going to kind of quote unquote solve this, first thing we would do is multiply out by our denominator and get just our numerators. And there's no reason to actually physically do that. We'll just set our numerators equal. Okay, so we know that should happen there. So if we set our numerators equal, 3x plus 11 on the left side, over here on the right side, A times x plus 2 plus B times x minus 3. Okay, now, again, making this clear down below here, this has to be true again for all x again. Yep, and no matter what x I got there, that's got to be true. Okay, now, next thing here I want to kind of point out here, folks, or acknowledge is that, I'll put this in blue up here, box this up. That step right there, I will never write down again. Okay, because all I care about is the numerator part of that, and I can get the numerator part of this thing without physically writing it down. If you want to write it down, be my guest, okay? But I'm never going to write this part that I kind of boxed up and blew up here because it's just not needing it. All we need is the numerator, and I can always get the numerator simply by saying A times what's missing plus B times what's missing plus C times what's missing, et cetera, et cetera, et cetera. Yeah, so basically I'm going to write my numerators down here, and then I'm going to, in my head, pretend I wrote the denominators down and walk through. Okay, so, and you guys can do the same thing as well. Saves a little bit of work with this stuff. Okay, now here is where the trick comes into play, folks. Okay, now again, like I said, there is a way that always works, and I will show it to you eventually. But the problem again with the way it always works is that it just is long and painful and easy to screw up. Okay? So generally speaking, I try not to do that if I don't have to. Again, one of the rare times I will kind of encourage tricks. This is one of them. Okay, so what I'm going to do is come back up here again and say, hey, this thing up here has to be again true for every single x out there in the world. So in particular, it's got to be true for x equals 3, picked randomly for no reason whatsoever. Okay, so it's got to be true for x equals 3. So if it's got to be true for x equals 3, let's plug everything in. So over here on this side, 3 times 3, 9 plus 11, so 20. Yeah. A times, well, 3 times 2, so 5. There it is. Oh, well, that's kind of nice. 3 minus 3, so 0. Yeah. You all agree? So if I just kind of randomly pick 3 for no reason, I plug it in up here, I got 20 on the right side, and basically 5 times a on the left side, because the, well, b times 0, of course, is just 0. So I don't need to bother writing that up, Jim. Yep. So I'll write it up the first couple times to make it obvious, but outside of that, I'm not going to mess with it. So yeah, so a is equal to 4. Yeah, Casey. So at this point, what we have then, yeah, is a really, really simple equation that we can very quickly solve for a. Yeah, so just divide both sides by 5, and we get that a is equal, sorry, equals, divide by 5, get a equals 4. Sorry about that. 4. So yeah, so a is equal to 4. Okay, and that's how that trick works. Yeah, and of course, keep in mind, folks, when I said this originally, 3, of course, was not randomly picked. Yeah, it was picked specifically for a reason. Okay, can you see why I picked 3? I'm going to kind of point out why I picked 3. Yeah, to get rid of the b term. Yeah, I picked 3 exactly to force that 3 minus 3 to be 0 then. Okay, so what would be another good number to pick? Correct, just randomly pick for no reason whatsoever. Yeah, -2, because that'll knock this term out. Yep. Okay, so if I pick it to be -2, and that's how this trick works, folks. That's also again why it only works if you've got basically, ax minus b. Okay, if they don't have that, it tends to not work very well. Right. So, and all tricks rely on this idea in some way. Right. So in this case, we plug a -2 in. What do we got here? So we got a -6 plus 11, so that's a 5. Yeah, if I do my arithmetic properly. I'll write down the 0 one more time, folks, and then never write it back down again. But a times 0 plus a b times -2 minus 3, so b times a -5. Yep. Just watch your negatives for those type of things there, folks. Easy to forget about them sometimes. And that goes to 0. Yeah, good. And then b is just going to be a -1. So you can divide both sides by a -5. And b is a -1. Yep. All right. So real simple to do the trick here. Yep. Okay, once you know what it is and what to look for. So dead simple. Like I said, folks, these, of course, obviously were not picked at random. Yeah, they were picked because I knew what the trick was going to be. Now you know what the trick's going to be as well. So there you go. Okay, so at this point, let's do the integral. So what do we got here? So we got, again, integral 3x plus 11. I'll go ahead and put the factored form in. You can do a factored form or non-factored form down here. It doesn't much matter, but factored form, because that's what we're working with. So just plug in. So again, all you got to be careful of, folks, is just make sure, come back up here to my decomposition. Yeah. Make sure to plug in A for A and plug in B for B. So I got to worry about it. Yep. Okay. So in my case, A was a 4, and that was, over x minus 3. Can't keep my ordering the same here. So x minus 3. And then at this point for the b's, folks, just be careful with the minus signs. Yes, so technically plus a -1, but I tend to bring that out to the front. You don't have to, of course. Just watch it with your minus signs. X plus 2. And then dx. Yeah. All right. Now, at this point, folks, this is where I'm going to kind of skip out this problem. So we did this part of this problem yesterday. Yep. Okay. So technically, we can do a u equals x minus 3 for the first term, say a v equals x plus 2 for the second term. Do some quick integrals on these, and for natural log v equals x plus 2. Yeah. Just don't forget when you do these, folks, to get the absolute value bars on the logarithms. Yep. If you don't do that, WebAssign will complain mightily about that. Okay. So oops, let me move this over a little bit. So we got room. This down here. X minus 3. Oops. Minus natural log absolute value of x plus 2. And just don't forget your constant. Yeah. Oops. There. And there we go. Simple, quote unquote. Yeah. Okay. I know I always say that, folks. I think in this case, though, again, the scene part isn't that bad of these things. You just got to remember what you got to do. Okay. And basically, unfortunately for you guys, you're also going to have to remember that table. Okay. So, but hopefully you'll do enough of these that the table won't be too bad. Okay. So as long as you can remember your table, partial fractions is not terribly bad. But now, I should be careful how I say that, folks. Partial fractions is not terribly bad, provided I don't make things terribly bad. Unfortunately, I can on occasion. I'm sure I probably did somewhat. Okay, so and what bad I mean, folks, is that the algebra can be really unpleasant on you sometimes. Okay, that's the way that always works, and you will see that here in a little bit. I'll definitely do a couple here for which the trick doesn't work, and we'll see some of the unpleasantness for these algebras. We'll get there. We'll get there. So, any questions on this before I move on to my next problem? Oh, sure. All right, there we go. Okay, so next problem here, example 2. So again, the first thing to do here, folks, again, is technically is to factor this denominator as much as we can. And it looks to me, yeah, like I can factor an x out of that. So I got what, 3x squared plus a 4x minus a 4 then. Yep. And then this quadratic here, folks, I'll let you guys check my work on this here in a minute, but this also in turn factors again. Okay, so make sure and check this, folks. If quadratics can factor, you are required to factor them. Okay, so just keep that in mind with this stuff. So if it can factor, you are required. So I'll write it down here. Oh, and notice again, folks, the degree of my numerator is 2. Degree of my numerator, or sorry, degree of my denominator is 3. So again, 2 strictly less than 3. So again, we can do partial fractions. Yep. Always should pay attention to that, folks. It's easy to forget to do that, and then there's those that one time out of 10 where it doesn't work. You get yourself in trouble because of it. Yep. Okay. So, and like I said, we'll do some examples of that stuff here down the road. So, fully factored denominator though is the x I factored out, and then the quadratical factor is x plus a 2 and 3x minus 2. Okay. So, let you guys check that if you want to, or you can just believe me. Take your pick. All right. There we go. Okay. Now, again, at this point, folks, these last two here, of course, pretty obviously fall into the ax plus b form again. Yeah. But so does that just that x by itself, because in the x by itself, a is a 1 and b just ends up being 0. Okay, so an x by itself is really just that first form again. Okay, so don't let that one get you all worked up. Simple enough, quote unquote. So a over x, and then b over x plus 2. Keep saying where I got my notes here. Yeah, good. Okay, and then c over 3x minus 2. Okay. So again, here's what we call our partial fraction decomposition. Okay. All right. Now, at this point, folks, again, I'm going to go straight to setting numerators equal. Okay, if you want to write down the term with the denominator in there, be my guest, but we don't really need it. Okay, so let's set our numerators equal. Okay, so x squared plus 4 on that side. Good. Now, again, remember, least common denominator over here, folks, is always that thing right there. Okay, now keep in mind, folks, again, as well, I can't stress this enough, that I know least common denominator always looks like this times that times that. Yep, because in these cases, it works out. Okay, now, it ain't always going to work out that way. My next example is not going to work out that way. Okay, so I want y'all to be careful about that. Yeah, so it's always that thing right there every single time. Okay. Again, I would say the majority of the time, but a good chunk of the time, the least common denominator is just multiply these out. Right? But again, there's that going to be that 40% of the time where that doesn't work. Right? So I want you to be careful about that. And we'll talk about why that doesn't work here when we get to the next example. All right, so what are we doing here? So again, it's a times what's missing. Well, what's missing for the a is the x plus 2 and the 3x minus 2. So a times what's missing. There we go. Yep. Plus b times what's missing. Well, in this case, what's missing is the x and the 3x minus the 2. All right, there it is. Same thing for the c. Well, we're missing the x, and we're missing the x plus 2 this time. Okay, so there we go. Okay, now, at this point, again, let's just start randomly picking some good values of x to pick here. So what's a good value of x to pick? Maybe -2. Yeah, sure. Let's try -2 because that'll knock out the first term and it'll knock out the last term. And notice that's the nice thing about this trick, folks. It doesn't matter how many terms I have over here on the left, as long as they're all nice linear terms to the first power, one number will knock out all but one of the terms. Okay? That's how this trick is always going to work for us. That's why we want to do it. Okay? So yeah, x minus 2. Be careful when you square it. Yeah, 4 plus 4, so 8. First term drops out, last term drops out, so we got a b times a minus 2. Minus 6 minus 2 times a minus 8. Yeah, if I do all my excuse me, arithmetic properly. Y'all agree with that? Yep. 16 divided by 16, or however you want to do it, of course, but it looks to me like it's going to be a minus, or sorry, not minus, but plus 1/2. Yep. If you're just watching your minus signs on this, if you do too much of this in your head like I did there, it's sometimes easy to forget about minus signs. Yep. There's a good x to pick. What's a good x to pick? 0. Yeah, that's a really good x to pick. In fact, I'd probably pick that one first just because it's easier for me. Okay, but however you want to do it. Got a 4 there. Okay, on this side. Again, 0 knocks out the last term, knocks out the middle term this time. Yeah, so we've got the first term left over. So a times 2 times a minus 2. And it looks to me like, oops, A is going to be a minus 1 in this case. Everyone agree? Yeah, good. Online, you guys following so far? Yeah, good. Now, at this point, folks, I'm not going to say what's the next good number to pick. I'm going to say what's the next number we need to pick. Yeah, it looks like a 2/3 here. The one problem with this trick, folks, is sometimes you're going to have to deal with some fraction work in this. That's the one problem with this trick. Okay, so just be aware that sometimes these numbers are going to be fractions. They're not bad. You just got to be careful with what you do. Yep. Okay, so I'll let you guys check my arithmetic on this, but plug 2/3 in over here. So 4/9 plus a 4 ends up being a 49 on the left side there. 2/3 will knock out the A, it'll knock out the B, so we've got the third term left over this time. So C times a 2/3, and then 2/3 plus 2, 8/3, so 8/3. Again, I'll let you guys check my arithmetic for the fractions there. And like I said, just be aware that sometimes, yeah, you got to deal with fractions, but it's, at this level, you're all capable. Do you want to? Well, maybe not, but you're capable. Yep. So, okay. Again, I'll let you guys check my work on this. C ends up in this case being technically a 40 over a 16, but of course we'll reduce that down to 5/2 just to make, well, the rest of the work go a little bit easier for us. Yeah. And there we go. So there then are our 3 values for our partial fraction decomposition. Yeah. Okay, everybody follow this. Yeah. Okay, now comment I want to make real quick before I kind of finish this problem out here. Be careful with the A, the B, and the C here. In this class, I try to keep them relatively nice, but that means you're going to get fractions on these occasionally. I don't want you to worry about it. To me, a 1/2 and 5/2 or a 3/17 or something is not particularly bad sometimes. Okay, I'll try to keep it so they're not 2 digits over 3-digit fractions, but you are going to get fractions occasionally. Yeah. Okay, so just don't worry about that when it happens. Okay, again, I don't worry so much about these numbers being nice necessarily. Okay, so don't worry about that when it happens. Right? Yeah. All right. Last but not least, then, not a hard problem to finish out then. So what do we got here? So we've got a, again, I'll go ahead and write the factored form down, whichever one you want to put down, doesn't matter. Makes sense to me to do factored form here, so I'll do that. There we go. Okay, so let's plug in. So A is -1, so -1 over x, plus B was a 1/2 over x plus 2. So 1/2 over x plus 2 there, and then plus C, so 5/2 over 3x minus 2. Yep. Back this way for some work here. So let's see here. So first one I hope is fairly simple, minus natural log absolute value of x. Yep. Yep. Plus second one again I hope is getting fairly simple with this stuff. Again, you could just do a u equals x plus 2. Yep. Okay, so natural log absolute value x plus 2. Okay. Now, third one. How did that 5/2 become 5/6? And I get emails every semester from students online telling me I screwed that up. It's online. But 5/2, but the 5/6 is correct. Where did 5/6 from? Better yet, again, how'd that 5/2 become 5/6? Because that is the correct answer. What would my u substitution up here be for this third term? Certainly, yeah. 3x minus a 2, yeah. Okay. So since my u would be 3x minus 2. So I'm going to write that down for this one just to make it really clear. Yeah. So u is equal to 3x minus 2. What's du? And Jordan, yeah, you got that. Good. Yeah, so Jordan got the answer right. But what's du? Du is a 3 dx, yeah? So when you do your substitution, you're going to pick up a 1/3 when you do your substitution, yeah? Because of that 3 sitting in front of the x right there, yeah? The problem with these logarithm integrals, folks, is so many of them end up being just kind of x plus 2, x minus 3, that kind of thing, that we just kind of naturally write down natural log of the denominator, and we forget to pay attention to coefficients in front of those x's sometimes, yeah? Okay, so I'll pick up a 1/3 for my substitution, so it's 5/2 times a 1/3, which of course is 5, 6. Yeah. Okay. So just be careful if you do these in your head, folks. And if you, I would hope that you get to the stage where you can do these quickly in your head. It'll make life a little bit easier for you guys doing exams and stuff like that. Yeah. So, but there, so everyone kind of follow again where that 5, 6 came from. Yep. I'll guarantee somewhere on the homework it's probably there. If it's not on the homework, it'll probably be on the exam. Yep. Just to kind of make sure you all can do this. Okay. All right. So everybody follow? Good. All righty. So just cranking through this stuff today. Okay. So next problem. Now, before we get to the next problem here, folks, there is an integral. This is a formula that I want you to have written down somewhere again, folks. Okay. So basically, there's kind of 3 formulas I want you just to have written down somewhere. That's integral of secant cubed, and this one I got my little red box sitting right here. Right now, technically, and if you had me for Calc 1 last semester, I showed you how to do this integral. But it is a Calc 1U substitution. It's also a fairly, I don't say unpleasant Calc 1U substitution. It's just not a natural Calc 1U substitution. Okay, so in this case, folks, what I'm going to tell you guys, or just tell you, is just have this written down somewhere, so that when you run across it, you can just trot it out. Okay, so rather than having to do a Calc 1 substitution. So if you want to do the substitution, be my guest, but it just takes time to do. Yep. Okay, so I'll let you guys avoid that substitution on this. And of course, it should make some sense, folks. You see my second term down here, x squared plus a 3. So yeah, we're going to probably need that formula for this exam. Okay, so all right. So let's jump into this. Now, a couple things with this one. Okay, first of all, note that my denominator is already kind of pre-factored for us. I tend to do that for these problems, folks, just so we all start from the same place. Okay, so next thing here to note is I got a quadratic that clearly doesn't factor. Also note that I've got a power on my linear term now. So linear being just a straight x there. Yes, so x minus 4 to a power. Yeah. Okay. Pay attention to those powers. Now, all the way back up to my table up here. Yeah. So x squared plus a 3, the third entry in my table up here. So I'll pick up one of these terms. Excuse me, we'll write down here in a minute. The x squared, the x minus 4 squared, though, is in this second entry here. Yep. Okay. So x minus 4, k being 2 here. So I'm going to pick up 2 terms. I'm going to pick up the first term of my formula here and the second term of my formula. You're noticing first term gets an exponent of a 1 on the denominator. Second term picks up that exponent of a 2. Yep. Okay. Had it been a 3, I'd pick up an a sub 3 over ax plus b quantity q, etc., etc. And you pick up literally 1 for each term, or sorry, 1 for each power. Yeah. Okay. Again, you hope I don't go pretty much past 2 or 3 on these because those get a little unpleasant past 2 or 3. Right? And I won't go past 3. Okay. Occasional 3, more often not the 2. Okay. All right. So let's scroll back down here. Yep. And let's kind of start this off then. All right. So we'll have our x squared. So it goes minus the 29x plus 5, all divided by that stuff there. There we go. Okay, now in my table for this first term, I used a sub 1, a sub 2, a sub 3, etc., etc. But that's because I didn't know what k was, so I didn't kind of know how far out to take my letters. Yeah. When it comes time to actually doing these, folks, I just tend to use a, b, c, d, e, f, etc., etc. Okay, so a over x minus 4 plus b over x minus 4 quantity squared. Okay. Now, again, if you want to use a sub 1, a sub 2, be my guest, folks. But like I said, when it comes to actually doing problems, I tend to just use a, b, c, d, etc. Okay. It's up to you on what you want to do there. Now, last term, the x squared plus a 3 here. So that's going to pick up a cx plus a d divided by that quadratic. Yep. Okay. Now, keep in mind with the quadratics, folks. Okay, it always gets folks in trouble with this stuff. The numerator for a quadratic, and by quadratic I mean an explicit x squared. Yeah. Technically, this first term's quadratic as well because that squared there, but the square is on the whole term versus square on just the x. Yep. Okay, so when I say quadratic, I'm talking the stuff inside the parentheses, not the power that might be on there. Okay. So quadratics always pick up, that ax plus b or cx plus d is in this case. Okay, don't forget to do that. Folks love to just put, say, just a c up here for these problems. Of course, that probably gets them in trouble. Okay, so be careful with that kind of thing. And again, the squared here does not affect my numerator. It's the stuff inside the parentheses that affect my numerator. Yep. Right. So be careful with that. Okay. Now we're going to set numerators equal. you're talking the first term here, Noah? I'm assuming that's what you're talking about. If so, yeah, it's always the problem with chat. Yeah, you know what you meant, and I wasn't quite sure what you meant. So yeah, it came from this stuff up here. Yep. Since I had a power on that thing, I pick up 1 for each power, right? So I had a 2, so I pick up 1 for the first power, 1 for the second power. And that's why I said you don't want me to go too much past 2 or 3 on those, because you pick up 1 term for each power. Okay. Now, setting my numerator is equal. Okay, remember my comment a minute ago about least common denominator, folks? What is it always? It is always the stuff in our original problem. It's x minus 4 squared times x squared plus 3, yeah? It is not that times that times that. Because if it was, it would be x minus 4 cubed times x squared plus 3, okay? We'll talk about in a second about why that's wrong. Okay, so I want you to be very, very careful with this. So again, it's always that thing right there, which is nice and convenient for you guys. You never have to think about what the least common denominator is, folks. It's sitting right in front of you, every problem, okay? All right, so what do we got? A times what's missing? Well, I'm missing 1 of the x minus 4s because the 2's sitting there, yep. No, Santiago, I'm going to want you to remember the chart. Yeah, this is something I want you to remember. If for no other reason, because anyone going up towards differential equations is going to need to know the chart up there as well. Okay, so yeah, I'm not going to give the chart on the exam. I want you to know. And do enough of these, and you're not going to really need to memorize it. You'll kind of have it down once you do enough of these, to be honest. So, oops, lost my train of thought here. Yeah, so a times what's missing? So I'm missing 1x minus 4. I'm also missing the x squared plus the 3. Yeah. So there we go. Okay. Plus b times what's missing. Well, I've got both of my x squared, my x minus 4s there. Yeah, again for the 2 from over there. I'm just missing the x squared plus the 3. There we go. And then the last term, cx plus a d. Well, what's missing now is both of my x minus 4 squares. Yep. So squeeze this in before I lose room here. And there we go. Okay, so I've set my numerators equals. Everybody follow with this. Okay, now I'm going to erase this line I'll put here in a minute, folks, but just because I don't run in here for anything else other than my quick discussion here at this point. Remember, technically, these are both supposed to be over denominators. Yeah, I'm not going to write them up because I'm not going to bother with them. Yep. And that's why we set our numerators equal. Yeah, we set our numerators equal. Let's come back all the way to this first example. Yep. We set our numerators equal because basically our denominators were supposed to be exactly the same. Yeah, so I can kind of clear my denominators out, right? So if we come back down here then, and again, and we screw up the least common denominator over on the right side. We say it's just this times this times this. Well, at that point, you've got x minus 4 squared on this side, but you've got x minus 4 cubed on this side. Yep. Okay. In other words, folks, you can't just blindly set numerators equal anymore at that stage, okay? Because your denominators are going to be different, and because they're different, I have to keep them around for the right, okay? Which makes these a lot more complicated, okay? Which is why you need to pay attention to getting your least common denominator, or again, not paying attention to it again, just always remembering it's always right there. Yeah. Okay. So there it is. Okay, so just be careful with that because that will get you in trouble with the rest of this work. Now, at this point, folks, my trick breaks down. Okay. There's one number I could pick. Yeah, I could pick x to be a minus 4 because that would knock out the first term, that would knock out the second term, that would allow me to find a b. Okay. Problem is though, is that the x minus 4 will always knock out that term, and the only thing over here is an x minus 4. Yep. So basically, I can't keep this around without keeping this term around as well. Okay, that's going to be a fact of life. Okay. There's also the fact that there's no real number that will ever knock out, and by knock out, I mean, of course, I mean turn to 0. Yep. Okay. There is no real number that will ever knock out x squared plus a 3. I mean, I could use some complex numbers there that would knock that term out, but we're not doing complex numbers. We're doing real numbers. Okay? So, in other words, I can't knock that b term out ever under these circumstances. Right? So, my trick will partially work to get me b, but it will not get me a, it will not get me c and d. Okay? Oh, and by the way, of course, as well, folks, if I leave this term here around, I've got both c and a d. Right? So we're going to have one constant, which my trick always works by having exactly one constant left over. Right? So, trick will not work here. Okay, for this problem. Now, What this means for us, folks, we have to do this the long way. Okay? And the long way means, unfortunately for you guys, over here on the right side and multiply everything out. Okay, remember I said you don't do this unless you have to. Yeah, you now see why you don't do this unless you have to. Right? So this is unpleasant. Yep. All right. Let's do some couple steps. Okay. This x minus 4 squared over here, so I have to multiply that out before I deal with this part. Yep. Okay. So quickly in my head here, that's going to be an x squared minus an 8x plus a 16. Yep. Okay. So yeah, keep that there. I'm going to probably run out of room here. Let's come all the way over here. Okay, now, when I say multiply all the way out, folks, I refuse to take this A and distribute all the way through because that's just way more to write down than I want to write down. Right, so I'm just going to go ahead and say A times multiply out. Yep. Okay, so if we multiply out here, what do we get? Looks like I've got an x cubed minus a 4x squared plus a 3x and a minus a 12, it looks like. Yep. I'll get my ability to quickly multiply that stuff out, I hope. Second term, again, I'm just going to leave it alone there, folks. You could technically, you're supposed to multiply that b through, but hey, it's more to write down somewhat. Yep. Okay. Oops. Yeah. Okay, last term. Now, I did this first term over here yet. No, I didn't use that word FOIL out things, although most of you learned to quote FOIL things in an algebra class yet. I hate FOIL with a passion. Right? Why do I hate it with a passion? Because it only works if you've got these two what are called binomials. Yeah? It only works if you've got a product of things with two terms each. And it's not two terms, FOIL breaks down. Yep. Okay, so I hate I hate that idea. I realize why they teach it. It's a good way to kind of get you used to doing this stuff. But it always, all it ever does though is it focuses in on things that look like this. And then you get things that don't look like this. Cx plus d times this mess over here. Yep. Okay. FOIL breaks down. And remember, all FOIL is telling you to do what? It's telling you to take the first term here and multiply it through everywhere over here. Then take the second term, multiply it everywhere through over there. Yeah, it's a quick way to remember how to do that. Yep. So take Cx, multiply it all the way through. Take d, multiply it all the way through. Yep, simple enough. Okay, you're capable of doing it. Just remember how to do it. So again, I'm probably gonna have to move down here on a line here. I'm gonna run out of space here, but let's go through. So Cx cubed, okay, minus 8Cx squared. Go, and then 16Cx there, I guess. Yep. Come down here for the d part of things. Now, in this case, I'm going to go ahead and multiply the d through to make it clear that's what I'm doing here, folks. So plus dx squared minus 8dx plus a 16d. Okay? So, again, there is nothing in this work that's hard. You guys are in Calc 2, meaning you're all capable of doing this algebra. It's just really easy to screw up. Right? You get in a hurry, you don't pay attention, you lose track of signs, you forget to multiply a d through or something like that, folks. It's really easy to mess up. Yeah. Or if you got bad penmanship like me, my C's start looking like parentheses after a while, and I get myself in no trouble. Okay. So basically, again, folks, just be careful with this stuff. Yeah, try to get too much of a hurry. It's just so easy to screw up. Right? Cannot stress that enough. All right. Now, the next part of this. Okay. In my head again, I'm going to take this A over here and multiply it through, take the B, multiply it through. Okay? Just in my head, let's do that, which is why it's easy to forget to do it. Yeah. Okay. But easier to write down without doing it. So I'm going to write it out here and in my head try to remember to do it. Now, what I want to do at this point, folks, is collect up all the like terms. What I mean by like terms, I mean all the x cubes together, all the x squareds together, etc., etc. Right? So let's do the x cubed first. Looks like I got an x cubed, and I'm going to do, I got my color stuff here. I'm going to do these in color. Yeah. So I've got an x cubed sitting there, and I've got an x cubed sitting there. Yep. So at that point, I'll have an a plus a c, and I'll factor the x cubed out of both of them. Yep. Okay, so a plus c times x cubed. All right. Now let's hit the x squared term. So what do I got? I see an x squared sitting here. Remember, I got to multiply that a through. I see an x squared there. Multiply the b through. I see an x squared there, and I see an x squared there. Yep. Okay, so let's add them all up here again, factoring the x squared out as I go. So minus 4a for the first one, plus b from the second one, minus an 8c from the third one, and then plus ad from the fourth one over here times an x squared. Yep. Okay, now Next thing here, folks, that I'm going to suggest that you do in some way, shape, form, or another as you do this. Mark them off in some way once you have collected up. Okay, because there's so many terms here that it's going to be easy to get distracted. You know, if a phone call come in or something, or you know, in my case, a cat comes by and decides it wants to walk over my work or something. You know, I forget where I'm at, and then I forget to deal with the term. Yeah. Okay. Or again, a bad case like me, bad penmanship, and a 3 starts looking like a 2 all of a sudden, and you forget to deal with it, or something along those lines, deal with it twice, etc., etc. Okay, so do something to mark them off as you go. Right? For my case, I'm kind of marking off with red here, of course, but just something to say, hey, I've dealt with that term. Okay, and then when you're done, go back and check and make sure you have dealt with every single term. Okay, something I really stress enough to do. Okay, now again, at this point, let's do the X's. Go through a little bit quicker this time. So the first one I see is over here. So I'll mark them off as I go. So it looks like a 3A. Let's go back to the black. So 3A. And then no X's in the second term. That's kind of nice. I see an X term sitting over here. So a 16C. Go. And another X term sitting down here in that last one. So minus 8D. All that times X. Yep. Okay, everybody follow? And let's just come down here again for a little bit of space. Constant terms now. So constant terms, I see just a minus 12 sitting there. So that's going to be this minus 12 times an A. I see a constant term sitting right there. So a 3B. It is. And then my last term is over here, 16D. So plus 16D. And then it looks like I have dealt with every term. Good. So I've got everything done. Okay, nothing double up because I was paying attention. Nothing missed because I was paying attention. So there we go. Okay. Now, everybody kind of follow what I did there. Yeah. And again, like I said, at this point, you can see why you don't do this unless you have to, right? It's too easy to mess them up. Now, next thing to make a point here, folks, is every term over here had better have a letter in it somewhere, right? I better not see it's a 12 by itself, or just a 3 by itself, or just a minus 8 by itself, or something like that. Every single term needs to have a letter in it, right? This is important, okay? It's wrong if it doesn't, the way these things are set up, okay? So be careful with that. Now, at this point, folks, again, remembering what we're trying to do here, okay? We're trying to set up A, B, and C, and D so that my right side over here ends up being my left side over here, yeah? Okay, or better yet, so that all of this mess over here has to equal that thing right there. Okay? Now, that promptly then tells me, what does A plus C have to be? Because A plus C is the coefficient of x cubed over here on the right, yeah? What do I not see on the left? I don't see an x cubed over there anywhere, yeah? And since I don't see an x cubed over here anywhere, what does A plus C better be? It better be 0, yeah? So you knock the x cubed term out on this side, right? So the A plus C had better go to 0. I'll write this down here in a second. Let's kind of make it clear. Everything's still kind of still on my screen here. The x squared term. Over here on the right, I've got this horrible mess over here on the right. Yep. Okay. But on the left, what do I have? I've got just a single x squared over here. By single, I mean a coefficient of 1. Yeah. So what is this thing supposed to be then? That better become 1. Yeah. Because the x squared term on this side has to equal the x squared term on this side. Right? So the coefficient on this side equals the coefficient on this side. That's 1. What about the x term? So the coefficient of the x's on the right have to be the coefficient of the x's on the left. So this coefficient on the right, what's that supposed to equal to then? Negative 29, because that's the coefficient of the x's over here. Yeah. Okay. Last but not least, I'm going to write this all down here in a minute. All of my constant terms here. Yeah. So all of my constant terms over here on the right have to equal my constant term on the left, meaning that this constant term over here had better equal to 5. Yeah. Okay. Good. So there it is. Okay. Well, what I'm going to say here is set coefficients equal, folks. Okay. So that's how I was going to write this out. So we're going to set coefficients equal. All right. And the way I'm going to write this is like this. So I'm going to say my x cubed terms. Okay. And so we're going to have an a plus a c. Oh, sorry, plus a c. So a plus c equals, well, again, scroll back up here. equals 0 because there is no x cubed term on that side. Yep. Okay, so a plus c has to equal 0. X squared term, horrible mess to write down, but there it is. So minus a 4a plus a b minus 8c plus a d. Again, x squared on the right has a coefficient of a 1, so that had better equal to 1. Okay, and then x to the first power. So again, over here. So I've got a 3a plus a 16c minus an 8d. Come on, scroll for me. Oof. Get scroll here in a second. There we go. Again, as we talked about a minute ago, coefficient of the x is over here is a minus 29. So minus 29. Yep. Again, just don't forget that minus sign when you have such coefficients equal. Easy to forget. Yep. Okay, last but not least, then the constant terms here, folks. I tend to denote the constant terms as x to the 0 because it kind of follows 3, 2, 1, 0. Yeah, x to 0 being 1. So for me, constant term. Yep. Again, you don't have to do it this way, folks. It's just the way I do it because it's the way I've always done it. Okay, so there it is. So we have my constant terms from my stuff up here, minus 12a plus a 3b plus a 16d. And if I remember right, that has to equal to a 5. Yeah. Yeah, good. So it has to equal to a 5. Yeah. Close to like a 5 there. Clear some notes there. There we go. All right. Good. Plenty of room. Good. I wouldn't run out of room for this problem. Okay. Now, this, folks, is the real mess of these problems at some level, right? Now, again, obviously there's mess up here. They're going to pretend that there's not mess up here. Yeah, obviously we got mess up here. Okay, but this is something that, in theory, everyone knows how to do in this class. You've been through an algebra class, right? You know how to solve systems of equations. The problem is that in an algebra class, you probably did 2 equations, 2 unknowns, and the occasional really hard 3 equations, 3 unknowns. And that was it. You walked away from that point. Never anything past that. Yep. Right. Now, in this class, it is not unusual to see 4 equations, 4 unknowns, 5 equations, 5 unknowns. But you're going to see systems that look like this, folks. Okay. Now, having said that, though, okay, these systems are nowhere near as bad as they look. Right? I know they look bad, 4 equations, 4 unknowns, but they're not bad. Now, I'm not going to do the work for you. Okay. I'm going to talk your way through a little bit of this. What I want you to do after class is go home, sit down, and see if you can solve this system, get the answers I give you. Okay? So, first thing I'm going to take a look in this system is this first equation right up here. A plus C equals 0. What does that tell me? A is a minus C or C is a minus A. Take your pick. I don't care how you want to do it. Yep. Okay. You're going to see a lot of these equations in these systems, folks. Okay. So you're going to be able to very quickly reduce down to fewer variables. Okay. So A equals minus C. Replace that A with the minus C, that A with the minus C, that A with the minus C. Yep. Okay, you're now down to 3 equations, 3 unknowns. Okay. Oh, and notice as well, folks, for this third equation right here, you now have 2 C's and a single D. So what can you do? You can either solve this for C in terms of D or D in terms of C. Take your pick again which one you want to do. It doesn't matter. Right? So A equals a minus C. I'm now down to C's and D's in this equation. So maybe solve for C in terms of D. Yep. Okay. Plug that in here. Oh, there are no D's down here. Oh, let's take back. There's going to be a C down here because you plug a C down here. Yep. Right. So, but now you're down. So I'll let you guys check the work on this. You're down to this equation here and this equation here, and that's going to be in terms of B's and D's only, I think. Right. So at that point, you're now down to 2 equations, 2 unknowns, which I am confident everybody in this class can deal with. Right. So you solve for your B, you solve for your D, and then come back up and say, now I know what A and my C are as well. Down on me there. Come back. Back over. Back. There it goes. So, but basically, folks, the systems aren't as bad as they look. You'll be able to very quickly reduce this thing down to 2 equations and 2 unknowns. Okay. So go home, see what you can get on these things. Okay. Make sure you get the same answers I'm going to get. Okay. And let me find my answers. System. Yeah, good. Okay, so you go through and do all your work here, folks. You should end up with A equaling 1, B equaling to a minus 5, C equals to minus 1, and D equals to a 2. Okay, now, again, folks, be aware, again, these are really, really nice numbers, but for these systems, I try to keep, at least for you guys at this stage, I try to keep these things super nice. Okay, you might get the occasional fraction. And at that point, I'll probably try to keep it as simple as a 1/2, 3/2, 1/3, that kind of thing. Okay, so I do try to keep these relatively simple at this stage. Now I should be careful that that's for exams, folks. Comes to the website. That stuff. Yep. So you might see some mess on these, but I'm sure they simple for you. Questions with that? Everybody follow? Well, despite the fact I just skipped out, some of the mess here. Yeah. But there it is. But like I said, in theory, you're capable of doing it. I'm confident you'll. So, okay. To cut out for you, Jordan, to cut out for everybody. It better not have been everybody. Scream of rage is going to come into play here. Don't do this. I'm assuming it's back now, though. Yeah. Okay. Yeah. So it's just a real quick one. Yeah. Okay. Yeah. Okay. Good. So it's not a repeat of what we had on Friday there. So, personally, folks, I think my guess here is basically it's kind of the 9 to 10 o'clock hour, and everybody's getting up, everybody's coming to campus, and everyone's hitting the network at pretty much the same time. So I think the network's probably just kind of cramming on us. Because I never have these problems in my first class right before this one. I never have problems in the class right after this one. It's just this class. And so I think it's basically everyone's coming to campus, everyone's getting up, and the network is just getting clogged with stuff going on this time. Okay, so we'll try to keep it up. But yeah, basically what I was saying is that, again, on exams, I'll try to keep these things simple, but there's a possibility that on WebAssign, the numbers going to be a little bit messier. Okay, so just be aware of that fact. Messier for WebAssign potentially, and for exams, I'll definitely try to keep them really nice and simple for you guys, just for less to write, less to mess. Also, a good way to check for you guys. Yeah, if you guys end up with a 5-digit over 6-digit fraction in this mess, find your mistake because you made it. Okay, so good way to check for mistakes. Yep. Okay, at least on exams. Okay, so all right. So we hopefully sound is back still. Please holler if it is. Okay, good. Now I'm paranoid again. Okay, so let's see if we can at least get through where we at for time here today. Where are we at? Okay, yeah, good. So we can finish this out by the end of the day here. I think we can. Maybe think about the next one a little bit here. All right, so where's my there it is. So x squared minus 29x plus 5 all divided by x minus 4 squared x squared plus 3 dx. All right. So again, being careful to plug in is appropriate. Yep. So a is 1 over x minus 4, and then b is a minus 5. I'm going to put that minus sign out in front. You don't have to. That's kind of my habit. X minus squared. And then the last. So see. Okay. Now, at this point, got a little bit of work I got to do here yet. So let me leave. Yeah, let's leave the first two terms alone here for a sec. Yep. Back down. Say 1 up there. Yep. Right. So this formula works if there is a 1 up in the numerator, because it looks an awful lot like my denominator. Yeah, I've got x squared plus a 3. Right? Oh, also notice, folks, that the 3 is a squared, so a is what for my problem? A square root of 3. Yep. A squared is equal to 3, so a is equal to square root of 3. Yep. Okay. So be careful with that. Yep. So a squared is 3. A squared of 3. But more importantly as well, I got a 1 up there. What do I not have up there? I don't have a 1. Now, the 2 I don't have a problem with. I can always factor 2 out if it was just a 2. But I also have that x sitting there. Yep. Okay. Also keep in mind, folks, when we see a fraction thing here, the first thing we should always ask ourselves is what's the derivative of my denominator? Because that might tell us what our substitution has to be. Yep. And derivative of our denominator is 2x. 2 times x, not 2 plus x. Yep. Or x plus 2. Right? So basically, if I had just an x here, don't care about the minus sign. If I have just an x up here, I could do a quick little u equals x squared plus 3, walk away, be done with it. Yep. Okay, but I've got the 2 up here, which causes a problem for that substitution. But the x also causes problems for that formula that I had up above. formula I had above doesn't want an x up there. Yeah. So suggestions. What can I do? Want a suggestion for me? What could I do here? Not substitute yet. We'll do it eventually. Michael, I don't want to factor an x out because if you factor an x out, you're going to have a 2 over x sitting here, gets you in trouble. Not a bad idea to factor it out because it's not going to do any good. Or even an x out here, not going to do any good either. So not a bad idea. You're all missing kind of the easy part, which I expect at this point. How about we just break things up? Because if I don't have an x, I can do my formula. If I don't have a 2, I can do a substitution. Yeah. So let's just break it up. Yeah. X over, I'll put the minus out front. X squared plus a 3 plus 2 over x squared plus a 3. Yeah. So basically, folks, when you have x plus or minus a number up here, yep, split it up. Okay. The x you can do a substitution on, and the number will give us our formula that I had above. Okay. Is that clear to everybody? Everybody follow? Yeah. Okay. So in a couple of minutes here, folks, leave yourself a line here. I'll put a couple things in here between the two steps here in a second, but kind of run out of time here, so I'm not going to write everything up here. First term, I hope you all can do. Natural log absolute value of x minus 4. So I hope that's one. At this stage, you're all kind of getting good at doing even just from today's classes, okay? Do that second one. Plus, and yes, that's a plus, 5 over x minus 4. We can do that. Think of that as 5x minus 4 to the minus 2. Yeah. And then I can do a u equals x minus 4 on that term. Yeah. So this becomes 5u to the minus 2. Integrate u to the minus 2. You pick up u to the minus 1 minus u to the minus 1 for the new exponent. Yep. Okay. So minus and the minus sign for my substitution go plus 5u to the minus 1. Went ahead and brought it back down to the bottom and substituted back in. Yep. And now for Webb sign, you can put in 5 over x minus 4 or 5x minus 4 quantity minus 1. It doesn't care. Right. But since I can kind of do this one in my head, I went ahead and do this one in my head. Right? But again, folks, there's a substitution I used for the work I did for that one there. Yeah, you agree? Hopefully. Second term, or third term, I should say. Minus 1/2 natural log x squared plus a 3. And again, where did that 1/2 come from? Yeah, good. Again, in this case, I'm going to do u equals x squared plus a 3. Yep. And of course, du is a 2x, so I got to bring that 2 over. I'll do my substitution and pick up a 1/2 for my substitution. Yeah. Okay. Everyone follow? Yeah. Okay. Last but not least, then, plus 2. Kind of factor that out in my head for my formula. So there's my 2. Okay. Again, as we talked about a minute ago, I'll put this here. If a squared is 3, then a is square root of 3 for my formula. Yep. Okay. So I'm not going to scroll back up because we're going to kind of run short on time here, but it's 1 over a. So 1 over the square root of 3. But I'll put that 2 in there because I factored the 2 out. Yep. And then inverse tangent, so minus 1 or arc tangent, ARC tangent, if you want to do that one. Again, for Web of Science, probably best to do arc tangent, just for ease of typing stuff in, okay? Either one's going to matter. It's not going to matter, though. I'll just type it in properly. And then x over a, so over square root of 3. Then just don't forget on these really long problems, ever-present constant of integration, yep? Oh, done. Quote unquote. Yeah. Yeah. And I assume it's going to take even longer. I built this up, so I was hoping even there I would give myself enough room. So, yeah, listen, folks, these are long problems. Yep. Okay. Keep in mind as well, again, folks, like the trig subs, that this first one was really long because of all the discussion stuff I had to do. Yep. Okay. It'll go a little bit quicker for the next one, so I don't have to do quite as much discussion for the next one. Okay. But these are long problems, folks. Okay. If you have not started the homework, folks, please get started on it. Yeah. Okay. When's homework due again? Yeah, I think I said Friday. Yeah. So Friday. Yeah. Okay, good. Yeah. So I thought I said Friday. I want to make sure I said Friday. Okay. So Friday. If not, it's going to have to push it back to Friday. Okay. So Friday, we will finish this up tomorrow. Okay. Probably do the next section as well, because the next section is going to take me all of about 15 minutes, maybe 10 minutes, 15 minutes to kind of rip through real quick. It's a real short section, no examples or anything. And then we'll have a help session on Thursday, which I'm assuming will probably be devoted mostly to trig subs. We can do some partial fraction stuff as well, okay, if we need to. And then homework on Friday. Okay. Also, the remaining time I got left here, and by time left, I mean hold you a couple seconds late here, folks. I was looking at scheduling today. As near as I can tell, as long as we don't have any more technology snafus going on, okay, our exam is going to be exactly when I tentatively scheduled it to be, which is rare. I don't expect that to happen, but it did in this case. Don't expect the rest of them to kind of follow those tentative schedules. Okay, I'll bring a date down tomorrow tomorrow and/or Thursday or something like that. Kind of remind you, but basically that tentative date I put on that file over the general content and the Blackboard section. Okay, I think that's what it's going to be. I think it's going to be, if I remember right, 2 weeks from today. Okay. So I'll formally announce that at the end of the week for sure. Okay, but I think that's where our exam is going to be. Okay? So let's call it good here, folks. I'll stick around for questions if you got them, but if not, you are free to go.